In this video, we will be seeing about the three-phase fully controlled rectifier fed DC drive. In three-phase converter, we know we have 3 legs and 6 thyristors are there. And T1, T3 and T5, that is odd number of devices will be connected in the positive group or in the upper group, and in the bottom we have T4, T6 and T2. See, always follow this sequence. Okay, 1, 3, 5, 4, 6 and 2. So at any time only 2 devices will be in conduction, that is one from positive group, that is one from upper group and one from lower group. So only 2 devices will be in conduction at any time, and that too one will be from the upper device and one will be a lower device, so that the loop will be closed. There are 2 modes of operation. So we have seen that in single phase fully controlled rectifier and inverter mode. Here also same rectifier and inverter mode. Rectifier operation when alpha is less than 90 degree and inverter operation for alpha greater than 90 degree. So you can achieve both forward motoring as well as reverse braking. For three-phase circuit, it is necessary to understand the relation between the phase voltage and line voltage, so that it will be easy to draw the waveform. So let us write the phase voltage first. So VA, VB, VC are the 3 phase voltages which are phase shifted by 120 degree. So VA is Vm sin omega t, VB is Vm sin omega t minus 120 degree, meaning that VB is lagging VA by 120 degree and VC is lagging VA by 240 degree. Let us draw the phasor diagram for this. I am taking VA as reference. So angle is 0 degree. So VB is lagging by 120 degree. So at 120 you are drawing VB, and this VC is lagging by 240 degree. So this angle is 240 degree. We are drawing VC. Now take the line voltage. So what is line voltage? VAB, line voltage or line to line voltage. So we write it as AB. So VAB is nothing but VA minus VB. See, this VA minus VB. You can mathematically subtract these two and find the values, or from phasor diagram you can find it easily. Okay. Now to find VAB, we should know what is minus VB. We know what is VA, already we have drawn, but we want minus VB. So let us draw that. So VA is here. Where will be minus VA? Just opposite to it. So minus VA. For VB, minus VB will be here. For VC, minus VC is here. Now we want VAB, which is VA minus VB. So VA minus VB. So draw a parallel line. Find the resultant value, that will give you the line voltage. So your phase voltage is here, line voltage is here. So for similarly we can find for VBC and VCA. So VAB is equal to root 3 times Vm sin omega t plus 30 degree. Why 30 degree? Because what is the phase difference between these two? 30 degree is here. So you can write here 30 degree. Plus 30 because VAB is leading VA by 30 degree. So it is here. So it is leading by 30 degree, and you see the magnitude of VA is here, whereas VAB is greater, its value is root 3 times greater. So VAB is equal to root 3 Vm sin omega t plus 30 degree. Now to write for VBC, what is the phase difference between VA and VBC? Here you have 90 degree angle is there. So VBC is equal to root 3 Vm sin omega t minus 90 degree. For VCA, what is the angle? 180 plus 130 degree. So it is 210 degree. 180 plus 30, it is 210. So VCA is equal to root 3 Vm sin omega t minus 210 degree. So you remember VA, VB, VC as well as VA, VBC and VCA values. Now let us see how this three-phase converter works. So it is basically a three-phase converter supplying a RLE load. RLE is nothing but it represents a DC motor load. Okay. So where R is the armature resistance and this is armature inductance and E is the back EMF. Always try to draw this table which actually represents the circuit, this circuit, because it will be difficult to draw the circuit again and again. So you remember this pattern alone. Write ABC which represents the three phases A, B and C, and write the devices. Upper devices will be in odd numbers 1, 3 and 5, and bottom you have 4, 6 and 2. So this represents this circuit diagram. Now when two devices are conducting, so already I told one from upper device and another one from lower device will conduct. So here let us take T1 and T6 are in conduction. So this will be the path. When T1 is conducting, it flows through the load and then T6 will conduct and it will be returned. Now what will be the output voltage? You see here this point, this device T1 is conducting, so this A point is connected here, and this B, actually this B is connected. Since T6 is in conduction, it is a short, so it will be connected to B. So across the load what you have, A and B points are connected. So what will be the output voltage? That is equal to VAB, or I can write it as VA minus VB. So if you know the device conduction, you can find what will be the output voltage easily. Now let us learn the sequence of triggering in three-phase converter. So always make sure you write this table correctly. 1, 3, 5, 4, 6, 2. Only if you write this correctly, you can write the sequence like this. If you change this table, this sequence will change. Okay. Now we know that each pair conducts for 60 degree and each device conducts for 120 degree. So let us draw this table, and this has 6 rows. It means that totally you have 360 degree. 360 divided by 6 will give you 60 degree. So each box represents 60 degree. So initially we are assuming T1 and T6 are in conduction. So next sequence will be T1 and T2. This device plus another new device will be T2. Then T2, T3, T3, T4, T4, T5, T5, T6. After T6 it should come T6, T1. Okay, this will be in a sequence. You can see here T1 comes in 2 boxes. it means that T1 is conducting for 120 degree because each box represents 60 degree. T2 comes 2 time, T3 comes 2 time, T4 comes 2 time, T5 comes 2 time, T6 comes 2 times. So after writing this, we can write the output voltage directly. So here you see T6 and T1 are in conduction. So T6 is in B phase, T1 is in A phase. So your output voltage should be AB. So first variable always represents the upper device and second variable represents the lower device. For example, you take T3, T4. You see here T3 is connected to B phase and T4 is connected to A phase. So your output should be BA. Take T5, T6. T5 is in C phase, so VC. 6, it is in B phase, B. If you take any other combination, you can verify. T4, it is in A phase and T5 is in C phase. So you should write CA because C represents the upper device and A represents the lower device. That is, the first variable should represent the first upper device. So if you are thorough with this sequence, you can draw the waveform easily. So if you need some more clarification on three-phase converters or how you are going to draw the waveforms, you can refer to the power electronics topics which I have covered in the Read Electric Vehicle channel. I have also covered some topics in basic electrical engineering and solid state drives. If you have any doubts, you can mail to this email ID readelectricvehicle@gmail.com. Now let us learn how to draw the line voltage from phase voltage. So phase voltage, we know all the three waveforms are phase shifted by 120 degree. So VA starts at 0 and it becomes 0 again at 180 degree, then it completes at 360 degree. If you take VB, it will be lagging by 120 degree. So start from 120 degree and finish the waveform. And VC will be starting at 240 degree. So draw this side also. So you got VA, VB and VC waveform. Now we will draw the line voltage. So line voltage, if you take VAB, it is leading by 30 degree because it has plus 30 degree. It means that it is leading the phase voltage VA by 30 degree. So how to draw this one? Take minus 30 here and draw the waveform. So magnitude I have increased to show that it is √3 times greater. So draw somewhat higher in magnitude than this phase voltage. Okay. So it should start at minus 30 degree and follows the same sign pattern. Okay. So VAB we have drawn. Now we have to draw VBC. So before that we can draw VBA. AB, BA is just inverse of AB. So draw it like this. So dotted line represents the inversion of VAB. Now VBC, it is lagging by 90 degree. Here you have minus 90. So it is lagging by 90 degree. So you start your VBC waveform from here. So it is in green color. So this is VBC waveform. Now this will be VCB waveform. Just inversion of VBC is VCB. Next draw VCA. So it is lagging by 210 degree. So 210 is here. So draw from 210, you will get VCA. And just inversion of that that is like this, you have VAC. So all these waveforms you have to draw it correctly. Only if you draw it correctly it looks neat. Okay. So from that itself you can understand whether you have drawn it correctly or not. You follow the same pattern. First draw VAB, then draw the inversion of that. If you do like that, you can draw it correctly. Now first see how to draw the waveform when alpha is 0 degree. That is when there is when it acts like a diode. So this is for basic understanding, but when you are writing in exam, it is not necessary to draw for alpha equal to 0 degree. This is only for your understanding. In exam you can directly write or draw the waveform for motoring mode as well as braking mode. That is, any alpha less than 90 degree will be for motoring mode and any alpha greater than 90 degree will give you braking mode. So alpha equal to 0 degree I have drawing here only for your understanding. So this is the conduction table. So here you have to give the alpha from 60 degree only. Why 60 degree? You take VAB waveform. So this will be more positive compared to other waveforms only at this 60 degree. So always you should give triggering pulse only after 60 degree. So T1 should be given firing pulse here only. If you give somewhere here in between, the device will not be forward biased and it will not conduct. So always take this 60 degree as reference in 3-phase converters. So 60 plus alpha plus you have to add 60 degree because we know each combination will conduct for 60 degree. So add 60 degree to this starting point. So it becomes 120 plus alpha. Okay. From 120 plus alpha, you write this one this side. For next combination, add 60 degree to this one. So it becomes 180 degree. So follow the same pattern. So if you want more detail in this, you go and refer to the power electronics video, 3-phase converter video. You can get all the details. So now you have marked the instant for T1. Similarly, mark the instant for T2. So T2, now you have taken alpha equal to 0. For T2 instant, it should be 120 degree. So 120. For T3, it should be 180 degree. So this point. Okay, like that it will come. So top are upper devices and here are lower devices. Now we will mark this combination of devices here. So I am drawing from this point to this point. T1 is in conduction, then T3 from this 180 degree to 300, T3 will be in conduction, and after that T5 is in conduction. So similarly mark for bottom devices also. So now you will get this sequence. You see here. So T1 and T6. So T1 and T6 marked here. So it is the first combination. Next will be, you see here, T1 and T2 will come. Next T2, T3 will come. Like that, the same pattern you can follow it. So it will come easily. If you mark it correctly, it will come correctly. Now how to draw the waveform. So already we have seen how to get this output voltage variables. So 6 and 1 means 6 is in B phase, 1 is in A phase. So output should be upper device, lower device. So upper device is A phase, lower device is B phase. So output will be VAB. So now you follow VAB waveform. So this is VAB waveform. Then for second combination T1 and T2, your output should be VAC. So follow VAC waveform. Then for next combination output is BBC. So which is your BBC waveform? Green color. So follow that waveform. Again follow this pattern, you will get this as the output. So this is the output waveform. So though you know to draw or not, it is not a big issue in three-phase converter. If you know to write this table, you simply draw this one and mark the variables. So your output will be this one. So for motoring operation, we know alpha should be less than 90 degree. IA will be always positive because this is thyristor can carry current only in one direction. VA is positive for alpha less than 90 degree. So power is positive and speed is also positive. So you are getting forward motoring operation. So for this, what will be the waveform? So let us take alpha equal to 60 degree. Okay. You can take any angle less than 90 degree. I have taken 60 degree. So write this conduction table. 60 plus alpha will be, here I have taken alpha equal to 60. So 60 plus 60 equal to 120 degree. And what will be the ending period? 120 degree plus alpha. So alpha is 60. So again 180 degree. Similarly, you follow the pattern and fill the table. Now we will draw the waveform. First mark the instant of turning on. For T1 it should start at 120 degree and end at 180 degree. Okay, this combination will end at 180 degree. So T1, T2, T3, you mark the instant. So T1 it starts at 120 degree. T2 starts at 180 degree. T3 starts at 240 degree. Like that you mark all the instant, and here upper devices let us mark it and lower devices mark it and mark the combination. So once you finish this one, now take this table. During T1 and T6 conduction, output voltage is VAB. So where is T6 and T1? Here. That is from this period to 120 to 180 period, my output should be VAB. So where is the VAB waveform? This brown color waveform. So follow that waveform for this particular period. So for this period, VAB is here. So let me follow from 120 degree. So you start from here like this and follow the waveform till 180 degree. For next period, what is the output? VAC. So VAC waveform you follow from 180 to 240 degrees. So 180 waveform you follow this pattern till 240. Okay, so if you know to draw for one, just draw a similar waveform, mark these voltages, that will be your output waveform. Okay, so this is for motoring mode, any alpha less than 90 degree. Next we will see braking mode. So we know braking mode alpha should be greater than 90 degree. So voltage will be negative but current will be always positive. So power is negative. For inverter mode we have to change the polarity of E. So speed will be negative and you can do regenerative braking in this mode. So let us draw the waveform for this mode also. So let us take alpha equal to 150 degree and I have given the device and the firing instant. So firing instant how to find? 60 degree plus alpha. So 60 plus alpha is 150 will give you 210 degree. Again for this one, 120 plus 150 will give you 270 degree. So when it exceeds 360, you should again start from 0, or whatever value you get here, you subtract 360 from here. Suppose for T4 you are getting 390, means subtract 360 from this, you will get 30 degree. It means that again the waveform starts at 30 degree. Okay. Now we will mark the instant. So T1 should start at 210 degree. So 210 is here. So T1 is starting at here. Okay, see here, this pink color, T1 starts at here, and T2 starts at 270 degree. So 270 is here, you see, I have taken T2 here. Okay, like this you can mark everything and mark the combinations. Now the same table, what will be the output? VAB for T1 and T6. So where is T1 and T6? Here. What is the VAB waveform? This brown color waveform, but it is in negative direction. You see here, our T1 is conducting here only, but it is in negative direction. So you follow this waveform alone for this combination. So in negative direction your output will be there. That is why it is operating in breaking mode. Okay. Similarly, you draw for one combination and then repeat the same pattern. If you want to for T1 and T2, follow VAC waveform. VAC T1, T2 starts here. So VAC waveform will be like this. So next waveform will be like this. Okay. So you draw for one sequence and then follow, write the voltages directly here. It will be easy. So let us find the average voltage for alpha less than 60 degree. So V average is equal to, you can see that there are 6 pulses in one full cycle. So full cycle is 2 pi. There are 6 similar patterns are there. So 6 divided by 2 pi, and limits are 60 plus alpha to 120 plus alpha. So whatever value of alpha you can substitute it, 60 plus alpha to 120 plus alpha, V naught into d of omega t. So V naught is Vm sin omega t. So you simplify this one. So this is the average value. So all the formulas I have given to derive the equation. Now let us derive the speed torque relation. So we calculated average value, and this value is given as the input for the DC motor. So DC motor voltage equation is EB plus IA RA. What is EB? Km into omega m. So you find what is omega m from this equation. So omega m is equal to this minus IA RA divided by Km. So torque is equal to Km into Ia. Here you have Ia, but you want torque equation. So from this you find Ia is equal to torque by Km. Substitute here, you will get the speed torque relation. From this you can draw this characteristics. So this is for motoring mode and this is for braking mode. So the points to remember here are: 3-phase fully controlled rectifier fed drives give you 2 quadrant operation, that is first and fourth quadrant operation. Forward motoring and reverse braking are possible, and this is the average voltage, and this is for speed torque relation. And if you like the video, do subscribe to Read Electric Vehicle channel. Thank you.